We have y equals this, x equals that. T is the parameter between these two functions. We want dy dx in terms of t. Do note one fact, that being that the derivative of tangent inverse of x is equal to 1 over 1 plus x squared. That's just a fact that we will need. Also, note the following. So a quick observation. Note that dy dt divided by dx dt has the following properties. Check it out. So dy dt is being divided, so we're going to instead multiply by the reciprocal, which would turn that fraction upside down, dx dt, and that's good because the dt's reduce away, and you're left with dy dx, which is the goal. So our strategy is going to be obtain dy dt, obtain dx dt, find their derivatives, and then divide them because that will give us the desired result. So let's begin by finding dy dt. The derivative of this with respect to t would be dy dt equals, now the derivative of tan inverse is this. It's a ratio. It's 1 over 1 plus something squared. What goes in here? X. What's x? The original input, that content there. 2t over 1 minus t squared. However, it's not just this per se. You do have to respect the chain rule, which means you multiply immediately by the derivative of the inner function, this theta, this argument, this inner piece. So for now, forget everything, only focus on this fraction and on computing its derivative and putting it here. So the derivative of a fraction, we use the quotient rule. So we go the bottom times the derivative of the top. Well, the derivative of that is just 2. I'll put it there. So bottom derivative top minus the top times the derivative of the bottom. That's the derivative of the denominator, all over the bottom squared. So that's 1 minus t squared, quantity squared. So I'm going to clean this up using all kinds of algebra, and I will fast forward through that part because you don't need to see it, but it will be in the video nonetheless. So let me just fly through this. And we have 1 minus t squared squared. This perfectly knocks this out. And notice that we have t squared plus 1 and t squared plus 1 squared. So this one copy knocks out the 2, which leaves 1 copy remaining. So it's going to be 2 over t squared plus 1. So this is what we get for dy dt. We have 2 over t squared plus 1. Now, here on this paper, so now we'll compute dx dt. So dx dt is the derivative of this with respect to t. That's that there. And the derivative of tangent inverse of t would be this rule. But in terms of t, it would be 1 over 1 plus t squared times 1, where 1 is the derivative of t, which is just there. And so this, of course, just equals 1 over 1 plus t squared. Now, let's finish this. The goal is to find dy dx. So dy dx equals, according to our note from earlier in the video, dy dx equals dy dt divided by dx dt. So dy dt is that, 2 over t squared plus 1, divided by dx dt, which is this here, 1 over 1 plus t squared. And this is 2 over t squared plus 1 multiplied by 1 plus t squared over 1. These reduce away, so you get back a constant. So final answer here, dy dx equals 2. How about that?